Okay, so I think that I'm audible to all of you. So these are the doubts of some students, and I'll be solving these doubts. Okay, only few doubts are there, maybe one or two, but it was important. This is like urgent to solve. So I'll be solving these doubts. Okay, whomever have asked can see the YouTube video. Is it fine? So I think that I'm visible here also on the video, isn't it? Yeah. So video is fine here. I'll not check the background now. I'll keep the same background throughout the class. Okay. So background will be same. Maybe today, in between 8 to 9, there will be some solution of the previous IDG advanced questions. But leave that. Let us start it. Let me put it here on say pin. Okay, I pinned my video here. Okay, that's fine now. It's visible. So I've projected. It's a slide number 55. This will previous year questions will solve afterwards, not now. Today we'll solve just one or two doubts. Okay, that's why I'm here. So your doubts were these. Yeah, this was the doubt. I hope the student who have asked this doubt remember this. Maybe, isn't it? Yeah. Okay. Fine. So let us solve it. First, what's the way when we are not able to solve the question? What is the reason that we are not able to solve the question? You must think like this. Okay. But what is the reason behind that I am not able to solve the question? Okay. Okay, so let us see this question. This question is basically for your information, and let me tell you, this question is from motion in 1D. This question is from what? This question is from motion in one dimension. Okay, fine. I'll provide you the PDF of both of these question solutions. Okay. So see what is happening here is this. The question says a particle starts from rest and traverses a distance of 1 with uniform acceleration. It means L. This is basically capital L. Okay. And then move uniformly over the further distance, that is 2L, twice of capital L. Finally comes to rest after moving a further 3 capital L distance under uniform retardation. So it's negative acceleration, you can call it as per physical significance. Assuming entire motion to be rectilinear motion, the ratio of the average speed over the journey to the maximum speed on its way is what? Options are A, B, C, D. Okay. I'll not give you the time to solve now because you people have already solved this question. I mean, you've tried to solve. That's why it's your doubt. No. Okay. So I'll just directly solve it. So first we'll break the question into 3 parts. What it says in the first part. Let me highlight it again. Okay. I'll explain in a very depth manner. No issues. You can see here a particle starts from rest and traverses a distance L with uniform acceleration. So first line is this. So we'll write it first. Okay. So whenever you're not able to see in the exam, it is different. But when you are in a regular, in a like habit to our habit of daily studies. So what you must do is this: have patience towards solving the question, towards your approach. Okay. So what you do is this: the first line says this: a particle starts from rest and traverses a distance L with uniform acceleration. Okay. So this is a particle, say, having the mass m, although it's not required to write the mass m here. Okay. Now it travels what? It travels a distance. Always solve the question patiently, have patience, and like very clearly. Okay. So solution I'm writing it. This is your solution. Fine. So particle travels a distance L. Okay. With a uniform acceleration. So I'll write here. This is what? Acceleration A. Uniform matlab constant acceleration. Okay. So it will cover this distance, it will reach here. Let us find the time first. Okay, so time is what? Initially it was having the speed equals to 0. So we need the time, we'll use the second equation of motion, which says displacement is equals to ut plus half at square. Okay. Initial speed is how much? It's given 0. Okay. Displacement is given how much? It's given L. Half of at square. Fine. Also, because these are some random equations which I will make, which at the end you will find like this. These are really useful. Okay. So one more equation we'll use, which is this. I'll use different color for this. Let us use this color. So that is v square minus u square 2as. You may now think, sir, why you're using these random equations? Have patience, at the end you will get the answer. Okay, so this is 2a, displacement is what? L. I'm writing directly. Initial speed is 0. So we'll say v square is equals to twice a L. That's fine. So these are two equations which we are having actually. Okay. So let's then this is also equation we are having. Keep this equation with you. Okay. Next, they say that this is the first line. We have funded two equations. Let us see the next. Although this question can be solved very fast, but for explaining you, I'm doing this. Okay. Next is this highlighter. When it says, then the particle uniformly moves over further distance twice of L. And finally, so we'll see final what is happening, but not now. It says in between that then moves uniformly over a further distance to L. Uniformly matlab kya hota? What is the meaning of uniformly? Uniformly means with constant speed. Uniformly means what? Uniformly means with constant speed. Okay. So first of all, see now you're able to know that why I've used that, why I have written this equation. So see, यहाँ से यहाँ तक particle चला constant acceleration से, it has gained the speed which is this. This is equals to how much? V is equals to 2AL का root. This is the speed gained by the particle here. Okay, at this moment. Initially 0, but here the speed gain after traveling L distance with constant acceleration is how much? It is V equals to under root 2AL. It's very easy to find. Huh? For the beginner, it's somewhat, if you don't, if you are just have introduction with this chapter that is motion in 1D, then it will take time a little bit. But for the people who have already practiced, it's like, it's like more than like, you can solve this question in between 20 seconds, 25 seconds. Okay, this is a speed gained here. Now the particle will move remaining distance, which is given here, 2L with the same speed, that is V equals to under root 2AL. Okay. So since the particle is moving with the same speed, we'll use the simplest equation to find the time. What is the time equation? Distance upon time is equals to the speed or velocity. You can say displacement because here path is not changing, path is same. Distance and displacement path are same. Initial and final position same. And there's no variability in the distance or the path between the initial and the final positions. This is 2L by T, and the speed is how much? Under root 2AL. Okay? So this is the time for traveling 2L distance, and this one was the time for traveling L distance. Fine. So we have both the times. Now let me cover this in or contain this in a box like this equation. Okay, that's fine. We have TL time, we have T2L time. Fine. Let us see the third part. At third, it says finally comes to rest after moving further distance 3L under uniform retardation. So students, what is this? This is this thing that when particle covers twice of L distance with uniform speed, so the same speed is not increasing now. Initially, the speed is attained at a particular level, now the speed is constant. So here, when it reaches after covering 2L distance with the speed which is equals to under root 2AL, okay? So here it covers the distance which is equals to 3L. Okay, so here the distance is how much? It is after covering 3L distance, particle ka speed kitna hua? You know what the speed is now? It's nothing, because they are telling the particle retards and comes to rest in 3L distance after traveling after traveling 3L distance. So I will say like this, students, I will rub this arrow. I will put here what to put here. The particle is at now complete rest. It's sleeping, it's taking a nap maybe. After that the journey starts again, it never stops. Okay, so retardation is there, so there will be some A in the back or negative acceleration or deceleration or retardation, due to which speed decreases. Car applies the brake, sudden brake, and the speed decreases in a sudden time square. Okay, so here speed comes to 0. Let us find the time for this. Time, how will find? Anybody? Yeah. So this is what displacement, second equation of motion again, ut plus half at square. Okay. Ut is how much? I don't know. Yes, we know it. It's written here. U is this, which is V actually now. So V becomes now U, initial. 2al, ठीक है. But students, इस equation में it will take a lot of time to solve this, you know. ठीक है, so इसको neglect करते हैं. Let us back. So sometimes it happens. While solving the question, we can go in some, you know, a different kind of direction. But you can have a U-turn. So make a U-turn and come back. Okay. So when it clicks, make a U-turn. Okay. So as you'll practice, the questions will be easy. So we can use which equation? Think. Okay, this is the first equation of motion, which is the easiest, I think. So to apply here and get our, because our demand is what? To find the time of traveling of this particle. I mean, the time required, the time the time which this particle took to travel 3l distance. So initial speed is under root 2al. A acceleration, it's negative, so I will use the sign minus, opposite direction, because the final speed is 0, t3l. So from this I get an equation that is time required to travel this 3l distance with in a retardation manner, 2al. This is this equation. Okay. Now let us extract the time from all of these three equations. Okay. So the time extracted is TL, T2L, and T3L. Okay. So these are the times. Let us see. TL is how much? It is 2L by A ka root is TL. That's fine. T2L is how much? T2L is how much? It is, okay, it says this is how much? 2L upon under root 2L. Okay. So it is 2L upon under root 2AL. Okay. And T3L is how much? T3L is how much? It is 2AL upon A. It is under root 2AL upon A. So these are the conditions here. Okay, students. Everything is in the manner of AL. That's fine. These all things are common. So we have the times. Now what to do? Now it's given here. You have to find the ratio of the average speed over the journey to the maximum speed on its way. Maximum speed on its way. Okay? Student, one thing is very much clear. The maximum speed attained by the particle is how much? If the particle starts from the rest, it accelerates and it acquires a particular speed, then acceleration is 0. It moves with a constant speed, and again it retards to come to 0. So the in between scenario, that is for traveling 2l distance with a uniform speed, that speed is what? That speed is, what is that speed? Uniform speed is what? That uniform speed is the max speed attained. So I will say the max speed by the way attained by the particle is simple. It's under root 2AL, which I've already pointed out now. See this attained speed, which was acting as an initial speed for the uniform path 2L. Okay. Now the main one thing which is required to find is average speed. Students, we know the very basic formula, that is average speed, students, is defined as what? Total distance. Average speed is defined as total distance, okay, upon total time taken. Okay. Total distance, if you count it, how much it is? You know, it's very easy. L, 2L plus 3L. 3 plus 2, 5 plus 1 L, I mean 6L. Okay, it's easy. So 6L is the distance. L, 2L, 3L, 3L plus 3L, 6L. Total time is how much? Add this 3 times. TL, T2L, T3L. You know the description. Time required for L distance, time required for 2L distance, time required for 3L distance. Okay. So add these times. So if you'll see, okay, let us simplify this. If I simplify this thing, let us simplify, let me write it here. TL plus T2L plus T3L. Okay. Let us simplify. So TL plus T2L, for your ease of like, you know, for your convenience, I'm solving it in a separate sheet. So when you will see the PDF, it will be easy for you. So now it is under root 2L by A under root 2L by under root 2AL. So isko solve karenge. The numerator will get cancelled by the denominator. Okay, I mean, it will not cancel completely. You will have the factor of under root 2L above now. So it is like this. With the factor of under root 2L, this 2 will cancel with this. Okay, so let me mark the values. So I will say This is how much? Root 2. This will be root 2. This is root L. This will be what? Root L. Because similarly here, what will be? This is root A will cancel with this will be root A. This A will go deleted. Okay. So the values are coming now here is same. It is what now? It is under root 2L by A. You can see it. And under root 2L by under root A. Yeah, that's fine. This is also what? Under root 2L by under root A. Okay. This is what? Under root 2L by under root A. So this comes as under root 3 twice L by A. Fine. So average speed is how much throughout it? Total distance traveled upon total time. Total distance is how much? 6L. Total time taken is how much? What's the total time? This is 3 under root 2L by A. Okay. Fine. So what's the answer we are getting is? Anyone of you, what's the answer we're getting? So if we solve it, we are getting this factor as 2. This is under root 2. This will be as given as under root A. When you solve it completely, this will be A upper, and this will be under root L. This will be root 2AL. Root 2AL. Okay. This will be what? Under root 2AL. Average speed. This is average speed. The ratio is asked for what? Ratio is asked for average speed over the maximum journey to this. Answer is coming as 1 for this. Okay. Hold on, students. One mistake we have done. It's very easy. Mistake which we did is this. See, यहाँ पे तो L distance travel है, that's fine. यहाँ पे 2L distance है. So I've written 2L, no issues here. Okay, that's fine. Then what's the issue? 2L यहाँ पे लिखा. This is 3L. So I will write here finally 0. The time taken is how much? Acha, we need the acceleration value. It's very easy. We need the acceleration value for this. यहाँ पे इक्वेशन जो यूज करेंगे ये भी करेंगे v square minus u square twice a 3L. Initial finally 0. Initial speed 2AL. ठीक है? Or doesn't make sense again. It doesn't make sense again. Okay, so there is an issue, students. We'll say like this. यहाँ पे acceleration can't be same again. We can't keep this acceleration same for the because that was the L distance. Once the speed is gained in the L distance journey, the same speed can be constant for whatever distance. That's fine because no external force is there. But once it comes at a point for traveling the next 3L journey, okay, now they say that after traveling this 3L journey, the speed goes 0. What does it mean? I mean, deceleration is there, that's fine. But what does it actually mean? It means like this, this deceleration is not same in magnitude as compared to the first L distance. Because this is not L distance, this is 3L. So right here, acceleration is also different. This is A3L. So you will get A3L as what here? You can't get anything here. The thing is this. Initial speed is this. This is AL ka speed. Acceleration for the L journey. Acceleration is also different. Okay. So this I'll comment like this is 823. This is for 83 means what? A3L. This is A3L and this is what? AL. Now you'll get it everything. Okay. Rest of the things are the same. No issues. You can check it out. Rest of the things are all same. This is what? AL ki journey. This is AL. This is A for L. A for L. A for L. Okay. This is also A for L. Okay. Now this is what? This is 832, 232. This is 2AL. This is 2AL. Final speed, okay, achieved speed initiate was this is L ka. This is what? Twice of A, 3L into 3L. Okay. So we'll get the relation between both the accelerations. Acceleration during L journey. See, it takes time to solve the question. You know, sometimes if you want to explain in depth. Acceleration in the L journey, acceleration in the 3L journey. So this will cut, this will cut. So we'll get it. Acceleration in the L journey is 3 times acceleration in what? 3L journey. Okay. So we are having the acceleration relation. Now we can get the time. It's very easy now. Okay. Yes. So we have acceleration relation here, so I can make it in just one. Okay. So let us see what we have did. We have to erase some of the things here. Just erase all those things here. Yes, some things have to be erased. Okay. Let me erase this full. Just wait. Main thing is that ultimately question must be solved clearly. Okay. Now, if you see here, what is the issue? Nothing. So we need to write the times now. T for L is how much? It's simple. It's same. Okay. This is equals to 2L upon AL under root. So this is same. इसको नहीं मिटाना था मुझे. 2L upon AL under root. Time for 2L distance is how much? Time for 2L distance is, it is 2L under root 2AL. ठीक है. It's 2L under root 2L. So this is the point. So 2L journey के लिए time कितना लगेगा? It is 2L under root 2AL L. ठीक है. And for T3L journey, the time required is now it's different. It will be under root 2AL L upon A3L. That is different acceleration. Okay, now we have to simplify these things. So when I added this, this was fine. But for the second, if I see, this will be what? This is L. This will be also same. No issue. This will be also same. AL, AL. लेकिन इसके लिए जब हम देखेंगे, this will be different. ठीक है. This L and L, this will be at the denominator. It will be what? Under root. इसमें distance में change तो नहीं किया. 3A, 3 gets cancelled. Okay, that's fine. So we can write here that this acceleration was, this is what? A3. है ना? A3L is equals to how much? It is AL by 3. Put here this. A3L is equals to how much? कितना है देखो ऊपर इक्वेशन में. This is A3L is equals to, it's subscript AL by 3. Okay, so right here AL by 3. So we get, next time I'll solve it very fast. Okay, I mean today I just checked, I just picked the question randomly. Okay, so I mean as per your doubts. So this will be how much? This will come out to be 3 root 2 by AL. ठीक है. यहाँ पे कोई L values नहीं आएगा क्या? Yeah, this L is different. This is not in the subscript. So I'll keep here the same. This will be what? This will be twice के साथ L, like this. So now we have all the values with us. Okay, now we are having all the values with us. So T3 comes out to be, T3 comes out to be this. I have to erase this value. This is what? This is very simple. 3 twice of L upon AL. Okay. Yeah, that's fine. Twice of into L. This is what this will solve. It is under root 2L by AL. So now we have these values. If I count this, this will be how much? 3 twice of LAL plus 2 twice of L AL, because these are same. Complete will be how much? 5 twice of L AL. So we can say average speed is how much? Distance is 6L. Same. This is how much? This will be 5. Let me remove this. This will be how much? This will be 5. Okay. Okay, fine. So we are having the answer what? We are having this answer, that is 2 under root 2. It comes out to be how much, students? Find it out. Let me erase this. This will be 6 by 5 AL. Okay. Under root 2. ठीक. And this will be same, no issues. ऊपर वाला under root में चला जाएगा. ठीक है. ऊपर वाला किस में चला जाएगा? ऊपर वाला will go into under root. L भी चला जाएगा under root में. ठीक है. This is average speed. Now they're asking what? Very simple. Average speed upon maximum speed is how much? 2A L. L कौन से वाला है? A ये कौन सा acceleration है? L distance का है. ठीक है. So these both are same. Divide it now. So I will divide this with this equation. My final answer is this. So average speed which I am getting as equals to कितना है? 6 by 5 L upon 2 divided by max speed attained. Max speed कितना आया? This is equals to max speed कितना है? Yeah, same, no, under root 2al. Okay, this is very good. It is under root 2al into l. So this will get cancelled. This chum chum, this is cancelling. Any other thing? No. So we have the final answer is how much? Final answer, students, is this. That is 6 by 5. This is root 2. This is what? 2. This is what? 3. Yes, this is the true answer. Answer is 3 by 5. So average speed upon maximum speed is equals to 3 by 5, students. I'm highlighting this. Average speed upon maximum speed is 3 by 5. Okay, it's fine. Good. So your answer will be what? Which is your option now? Option will be what? Option will be this. That is C option. This is your answer. Okay, 3 by 5. Clear? So we have completely solved in depth now. Let us proceed to the next and end the class and this doubt session. Okay, because since it's not a class. The displacement of the particle moving in a straight line is given by the relation. Very good. It's easy. It's integration. We can just see and answer it. The distance covered by the particle first 5 seconds. Very easy, students. Displacement equation is given. Okay. So we'll say here like this. I'm just directly solving a solution. I'm providing you S equals to 6 plus 12t minus 2t square. Okay. Distance covered of the particle in 5 seconds. Simple, students. What it will be? Anybody can answer? कैसे करेंगे इस क्वेश्चन को? Displacement as a function of time is given. How you can find the rest of the things? I mean, distance covered by the particle. How you'll find the distance covered by the particle? Anybody? Any one of you students? What do you think? Okay, so do one thing. You try this question one more time, okay? Or you want me to solve? Tell. Okay, I'm giving you 1 or 2 seconds. I mean, like 1-2 minutes more to solve this question. Then I will solve it. Okay. So your time starts now. I'm giving you 2 minutes more to solve this question. Here we go. Now, try to solve. Use your mind. Use your mind, students. Use your mind. 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 The time has already started. Okay, 25 seconds went. Okay, so now I'm solving it. Okay, I have given you enough time. See, think like this. Now there's no such equation. I don't know what to do differentiation, what to do integration. I don't know now. Sometimes it looks integration, sometimes it looks differentiation. Simple है देखो पहले check करो displacement equation. Displacement is what? Just initial and final position dependent. Okay. So what you do is this. First, let us see how the motion is going on by this particle. How this particle is undergoing this motion. If you divide this equation with say, not divide, just integrate it. We'll get the velocity because differentiation of displacement is velocity, differentiation of distance is what? Speed, because it's magnitude, scalar. Displacement का क्या velocity vector आएगा, it will be what 12. I'm writing directly 40. You must know this differentiation. Let us see when this goes 0. If this goes 0, it means what? The particle is changing its direction. So it goes 0 at time equals to 3 seconds. So up to 3 seconds, this particle is moving in just one direction because this is displacement. This particle will be moving in just one direction. That will be the distance for the forward motion. Okay. I mean, when the direction is not changed till that point. So put your time equals to 3 seconds. When you will put time equals to 3 seconds. So for 3 seconds, the displacement is how much? It is 6 plus 12 into 3 minus twice of 3 square. This is what? 6. 3 to the 6, 3 to the 3 minus 3 to the 9, 9 to the 18. This is what? 18, 6. This is how much? 24 meter. So S equals to 24 meter will be such a motion that a particle starts, it comes, its velocity goes 0, maybe due to deceleration. Finally, it's 0 here in between 3 seconds, then it changes its direction, moves back. So again, by the symmetricity, we'll say what? Again, it is asked what in 5 seconds. So in 3 seconds, it covers like this. Okay? Okay, they're asking first 5 seconds. In the 2 seconds, it will go back. So let us put 2 here in this. Okay. So when I will put 2, this it will be in the negative direction. So the answer will be what? So for the next 2 seconds, displacement will be the magnitude of the displacement will be distance only. Okay. So this will be how much? It is 6 plus 12 into 2 minus 2 into 2 square. 6, 24, 2 to the 4 to the 8. This is how much? 24 minus 2. This is how much? 20. Okay, this is for 2 seconds. So students, just add this because these are now magnitudes. Displacement hai equivalent to magnitude, equal to distance. Okay. So add both of the distance, you will get is what? This is 24 plus 20. Answer is how much? It's 44. It's coming as this. What is your answer, students? Hold on. I did some mistake here, I think. Yeah. Oh, these are distances, no. And they're asking about net distance traveled. Net distance traveled. This will be same 44, no issues in this. I mean, the 2 seconds it will find this displacement. Let us check the forward meter distance. Am I right here? Forward meter distance. 6 plus 12t. Okay, students, now we will leave it. Okay, we'll see this doubt in the next class. Okay, there are some issues in this question. We'll check it out. Okay, so now I'm leaving it. Just try to solve it one more time. The method will be this only. It will change its direction and we have to see the displacement distance and all those things. Okay, till then, bye bye. We'll meet in the next class. Okay, I'll take this doubt again, solve it, and we'll start the previous year questions. JEE means or JEE advanced, maybe we'll see. NEET also will take. Okay, so bye bye everyone.